Hi guys, welcome to my YouTube channel. Today we are going to learn about chi-square test regarding a single practical problems. First one was goodness of fit. This is a following table of frequency distribution of cars sold at auto dealership during past 10 years. That's from Jan to October, and the cars sold of Jan month was 23, Feb was 17, March was 15, April 10, May was 14, June 12, July 13 and August 15, September 26, October 25. ಆ್ಯಂಡ್ ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅಂದರೆ 5% ಆಫ್ ಲೆವೆಲ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸಲ್ಲಿ ನೀವು ಆನ್ಸರ್ನ ಕನ್ಕ್ಲೂಡ್ ಮಾಡಬೇಕು. ಎಷ್ಟು ನಂಬರ್ ಆಫ್ ಕಾರ್ಸ್ ಈ ಡೀಲರ್ಶಿಪ್ಪಲ್ಲಿ ಅಂದರೆ ಮಾರಿರುವಂಥ ಕಾರ್ ಈಚ್ ಮಂತ್ ಸೇಮ್ ಆಗಿದೆಯೋ ಇಲ್ವೋ ಅನ್ನೋದನ್ನು ನೀವು ಹೈಪೋಥಿಸಿಸ್ ಮೂಲಕ ಹೇಗೆ ನೀವು ಕಂಡುಹಿಡಿತೀರಾ, ದಟ್ ಈಸ್ 5% ಲೆವೆಲ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್. 5% ಲೆವೆಲ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ನ ನಾವು ಫೈನಲ್ ಆಗಿ ಅದು ಒಂದು ಶೀಟ್ ಬರುತ್ತೆ, ಚಾರ್ಟ್ ಶೀಟ್ ಬರುತ್ತೆ. ಸೊ ರಿಗಾರ್ಡಿಂಗ್ ಅ chi-square, ಸೊ ಅದರಲ್ಲಿ ನಾವು ಆ ಡಿಜಿಟ್ಸ್ನ ನೋಡಿ ಕನ್ಕ್ಲೂಡ್ ಮಾಡುವಂಥದ್ದು. ಸೊ ಫಸ್ಟ್ ಒನ್ ವಾಸ್, ಇದು ನಿಮಗೆ ಅರ್ಥ ಆಗಲಿ ಅಂತ ಬರ್ತಿದ್ದೀನಿ, ನಲ್ ಹೈಪೋಥಿಸಿಸ್ ರೆಪ್ರೆಸೆಂಟೆಡ್ H0. ದಟ್ ಅಲ್ಲಿ ನೀವು ಏನಂತ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ ದ ನಂಬರ್ ಆಫ್ ಕಾರ್ಸ್ ಸೋಲ್ಡ್ ಅಟ್ ದಿಸ್ ಡೀಲರ್ ಈಸ್ ಸೇಮ್ ಫಾರ್ ಈಚ್ ಮಂತ್. ಇನ್ ದಿಸ್ ಆನ್ಸರ್ ವಿಲ್ ಬಿ ದಿಸ್ ಲೈನ್ ವಿಲ್ ಬಿ ಕರೆಕ್ಟೆಡ್. ಆ್ಯಂಡ್ ಆಲ್ಟರ್ನೇಟಿವ್ ಹೈಪೋಥಿಸಿಸಲ್ಲಿ H1ನಲ್ಲಿ ಹೇಳ್ತೀವಿ ಅಂದರೆ ದ ನಂಬರ್ ಆಫ್ ಕಾರ್ಸ್ ಸೋಲ್ಡ್ ಅಟ್ ದ ಡೀಲರ್ಶಿಪ್ ಈಸ್ ನಾಟ್ ಸೇಮ್ ಫಾರ್ ಈಚ್ ಮಂತ್. ಸೊ ಐದರ್ ಅದಾದರೂ ಆಗ್ಬೋದು, ದಟ್ ಈಸ್ ನಲ್ ಹೈಪೋಥಿಸಿಸ್. ಆಲ್ಟರ್ನೇಟಿವ್ ಹೈಪೋಥಿಸಿಸ್ ಕೂಡ ಆಗ್ಬೋದು. ಅಂದರೆ ಕಾರ್ ಸೋಲ್ಡ್ ಅಟ್ ದಿಸ್ ಈಚ್ ಮಂತ್ ಈಸ್ ಸೇಮ್ ಆಗತ್ತೆ. ಇಲ್ಲಾಂದರೆ ದ ಕಾರ್ ಸೋಲ್ಡ್ ಅಟ್ ದಿಸ್ ಡೀಲರ್ಶಿಪ್ ಇಸ್ ನಾಟ್ ಸೇಮ್ ಅಟ್ ಈಚ್ ಮಂತ್. ಸೊ ಇದನ್ನು ನೀವು ತಲೆಗೆ ಹಾಕ್ಕೊಳ್ಳಿ. ದ ಲೆವೆಲ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸು 5%. ಸೊ ಫಸ್ಟ್ ಸ್ಟೆಪ್ಪು ಏನಂದರೆ, ವಿ ಆಲ್ರೆಡಿ ಲರ್ನ್ಡ್ formula in our last class, that is absorbed frequency minus expected frequency whole to the square divided by expected frequency. So ನಾವಿಲ್ಲಿ ಡಿಗ್ರಿ ಆಫ್ ಫ್ರೀಡಮ್ ಕೂಡ ಕಂಡುಹಿಡಿತೀವಿ. ದಟ್ಸ್ ಫಾರ್ಮುಲಾ ಈಸ್ n minus 1. So we want to create a table, that is a month, that next column was O, that is absorbed frequency, and the next one was E, expected frequency. Next O minus E, absorbed frequency minus expected frequency. Next one was absorbed expected frequency whole square. We have 6 and the 6 whole square is 36, like that. And next we are going to calculate. So you can see this table, you can understand easily. Like number of observation is 10 and sigma of O is 170, that is 23 plus 17, 17 plus 15, 15 plus 10, 10 plus 14 and 14 plus 12, 12 plus 13, 13 plus 15, 26, 25 comes to 170. The expected frequency is calculated here, that is sigma O divided by number of observation, that comes to the sigma O, that observation, the total observation is 170 divided by number of observation, total observation divided by number of months, that is 10 months, is equal to 17. That is expected in his expected frequency minus observed frequency minus expected frequency, that comes to 23 minus 17 comes to 6. 17 minus 17 is 0, 15 minus 17 is minus 2, 10 minus 17 is minus 7, 14 minus 17 is 3, 12 minus 17 is minus 5, 13 minus 17 is minus 4, and 15 minus 17 is minus 2, 26 minus 17 is 9, 25 minus 17 is 8. So here we want to do it a whole square, that is 6 square is 36, 0 is 0. Here minus into minus 2 into minus 2 comes to 4. The minus will be eliminated. So same in all the cases, 7 square is 49, 3 square is 9, 5 square is 27, 25, 4 square is 16, 2 square is 4, 9 square is 81 and 8 square is 64. So here we calculate the whole square of, that is 36 divided by expected frequency, that comes to 2.117. So here 0 divided by 17 comes to 0.00. 4 divided by 7, that is observed frequency minus expected frequency divided by expected frequency. 49 divided by 17, 2.882. So the same way the following happens, and the overall observed frequency minus expectant frequency whole to the square divided by E is equal to 16.94. Okay, 16.94. So this is the calculated thing was 16. What we calculated was 16.94. Let me calculate degree of freedom, that is n, number of observation minus 1, that is 10 minus 1 comes to 9. So next part we are taking into critical value. Critical value is nothing but the chi-square distribution table that can be seen or downloaded in a Google. So you can get this significant level distribution. Here we have a significant level of 5%, whereas the degree of freedom is 9. See, here we have 16.91. So what we need to conclude, or we take a decision according to the tabulated of tested statistics, that is chi-square at 5% level of significance and degree of freedom is that the conclusion is tabulated is lesser than the calculated one. Here the tabulated was 16.91, that we calculated 16.94. So here the null hypothesis is accepted and the alternative hypothesis is automatically rejected. So here what we are saying is 16.91 is a tabulated thing, that is under the degree of freedom is 9, in that the 5% was 16.91, but what we calculated comes to 16.94. Here the 16.94 what we calculated is higher, so the null hypothesis is automatically get accepted, whereas alternative hypothesis is rejected. So in the same way we are doing, next one was independence test or independence of attributes. Here we have a sample of 15 workers of factory according to their gender, and the nature of works follows. So nature of works is technical and non-technical, and we have a total. So we have a male and female as for a gender, and we have a total. So here the technical was 200 for male, female it is technical 100, non-technical male was 50, female was 150, total of male was 250, total of female was 250, and whereas technical male and female is 300, non-technical total was 200, overall total is 500. So here they are saying that the test is at 5% significant where there is any relationship between the gender and nature of work. ಇಲ್ಲಿ ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅಂದರೆ ನೇಚರ್ ಆಫ್ ವರ್ಕ್ ಅಥವಾ ನೇಚರ್ ಆಫ್ ವರ್ಕ್ ಮತ್ತು ಜೆಂಡರ್ ಮಧ್ಯೆ ಏನಾದರೂ ಅವ್ರು ಏನು ಹೇಳ್ತಾ ಇದ್ದಾರೆ ಅಂದರೆ ಟೆಸ್ಟ್ ಅಟ್ 5% ಲೆವೆಲ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಅಲ್ಲಿ ನೀವು ಟೆಸ್ಟ್ ಮಾಡಿ, ಹಾಗೆ ಎನಿ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ಜೆಂಡರ್ ಹಾಗೆ ನೇಚರ್ ಆಫ್ ವರ್ಕ್ ಹತ್ರ ಇದೆಯಾ ಅಂತ ನೋಡಿ. ಇಲ್ಲೂ ಹಾಗೆ ಸೇಮ್ ದ ನಲ್ ಹೈಪೋಥಿಸಿಸ್, ದೇರ್ ಈಸ್ ನೋ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ಜೆಂಡರ್ ಆ್ಯಂಡ್ ನೇಚರ್ ಆಫ್ ವರ್ಕ್. ನಲ್ ಹೈಪೋಥಿಸಿಸ್ ಅಲ್ಲಿ ದೇರ್ ಈಸ್ ನೋ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ಜೆಂಡರ್ ಆ್ಯಂಡ್ ವರ್ಕ್. ಆಲ್ಟರ್ನೇಟಿವ್ ಹೈಪೋಥಿಸಿಸ್ ಅಲ್ಲಿ ದಟ್ ಈಸ್ H1 ಅಲ್ಲಿ ನಾವು ಏನು ಹೇಳ್ತೀವಿ ಅಂದರೆ ದೇರ್ ಈಸ್ ಎನಿ ರಿಲೇಶನ್ಶಿಪ್ ಬಿಟ್ವೀನ್ ಜೆಂಡರ್ ಆ್ಯಂಡ್ ನೇಚರ್ ಆಫ್ ವರ್ಕ್. ಸೊ ಇಫ್ ನಮಗೇನಾದರೂ ಜೆಂಡರ್ ಮತ್ತು ನೇಚರ್ ಆಫ್ ವರ್ಕು ಅಲ್ಲಿ ಏನಾದರೂ ರಿಲೇಶನ್ಶಿಪ್ ಇದೆ ಅಂತ ಗೊತ್ತಾದರೆ ವಿ ವಿಲ್ ಸೆಲೆಕ್ಟ್ ಆಲ್ಟರ್ನೇಟಿವ್ ಹೈಪೋಥಿಸಿಸ್, ಇಫ್ ನಾಟ್ ವಿ ವಿಲ್ ಸೆಲೆಕ್ಟ್ ನಲ್ ಹೈಪೋಥಿಸಿಸ್. ಸೊ ಲೆವೆಲ್ ಆಫ್ ಸಿಗ್ನಿಫಿಕೆನ್ಸ್ ಆಸ್ ವಿ ಆಲ್ ನೋ 5%. ಇನ್ ಕೇಸ್ ಅವ್ರು ಕೊಡಲಿಲ್ಲ ಅಂದ್ರೆ ನೀವು ಡಿಫಾಲ್ಟ್ ಆಗಿ 5% ಅಂತಾನೆ ಹಾಕೋಬೇಕಾಗತ್ತೆ. ಐದರ್ ದೇ ವಿಲ್ ಗಿವ್ 1%, 5% and many other digits. If they are not given, you want to put defaultly 5%. So step 4 ಅಲ್ಲಿ ನಾವು ಟೆಸ್ಟ್ ಆಫ್ ಸ್ಟ್ಯಾಟಿಸ್ಟಿಕ್ಸ್ ಅಂಡರ್ ನಲ್ ಹೈಪೋಥಿಸಿಸ್ ಹೇಗೆ ಟೆಸ್ಟ್ ಮಾಡ್ತೀವಿ ಅಂತ. ಸೊ ಆಸ್ ವಿ ಆಲ್ ನೋ ದ ಫಾರ್ಮುಲಾ, ದಟ್ ಈಸ್ ಅಬ್ಸರ್ವ್ಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಮೈನಸ್ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಡಿವೈಡೆಡ್ ಬೈ ಎಕ್ಸ್ಪೆಕ್ಟೆಡ್ ಫ್ರೀಕ್ವೆನ್ಸಿ, and degree of freedom formula was different under the independence attributes, that is R rho minus 1 and column minus 1, row minus 1 into column minus 1. So expected frequency the formula ಏನಂದ್ರೆ here it changes, that is row table into column table divided by n. So we have another table here, that is observed frequency, expected frequency, and observed frequency minus expected frequency. Next, observed frequency minus expected frequency to the whole square. Next, observed frequency minus expected frequency divided by expected frequency. Here the observed frequency was technically male was 200 and technically female was 100, non-technical male was 50 and non-technical female was 150. That observed frequency total comes to 500. And the expected frequency, we'll calculate expected frequency for each and every row and column. So here we have a 200, that is row total comes to 300 of 200 ರೋ ಇದೆಯಲ್ಲ ಮೇಲ್ ಟೆಕ್ನಿಕಲ್ ಅಲ್ಲಿ, ಸೊ ಅದರದ್ದು ಟೋಟಲ್ ಬಂದು 300 ಇಂಟು ಕಾಲಮ್ ಟೋಟಲ್ ಬಂದು 250 ಇಂಟು ಡಿವೈಡೆಡ್ ಬೈ ಓವರ್ ಆಲ್ ಟೋಟಲ್ ಬಂದು 500, ದಟ್ ಕಮ್ಸ್ ಟು 150. ಸೊ ನೆಕ್ಸ್ಟ್ ಒನ್ ವಾಸ್ 100 ಕಾಲಮ್ ಟೋಟಲ್ 250, sorry, yeah, column total 250 and row total was 300. Same here, 300 into 250 divided by overall total, that comes to 500. It is also same 150. And expected frequency do next one 50, that is non-technical male ali. So our overall total non-technical overall total bandi 200 into row total bandi 250, that comes to 200 into 250 divided by the overall total is 500, that comes to 100. The same way for expected frequency, that's for 150 non-technical female, the total was 200 into row total 250 divided by 500, that comes to 100. So these are the 150 for 200, 100, 150, 50. So yeah, I'll come again. Male technical 200 ಗೆ expected frequency 150 ಬಂತು, technical female ಗೆ 100, that comes to expected frequency 50, and observed frequency of non-technical male 50, that comes to expected 100, and observed frequency of non-technical female 150 comes to expected frequency 100. So 200 minus 150 50, 100 minus 150 minus 50, 50 minus 100 minus 150, 150 minus 100, that is comes to 50. So here the whole square was same for all the things, that is 50 square comes to 2500. So here we are calculating observed frequency minus expected frequency divided by expected frequency, that is 2500 divided by expected frequency 150, that comes to 16.67. Same to the next one, and next one was 2500 divided by 100, that comes to 25. Overall total is 83.34. So this is our calculation of observed frequency minus expected frequency whole square divided by expected frequency, that is 83.34. And next was we will go to the critical value, where we can find out the level of significance for 5%. The level of degree of freedom was row minus 1 into column minus 1. How much row we have? 2 rows we have, 2 rows minus 1, 2 columns we have, 2 columns minus 1. So that comes to 2 minus 1 1, 2 minus 1 1, 1 into 1 1. So here the degree of freedom is 1. So let me go for a tab, that is we have level of significance for 5%, the degree of freedom is 1, that is tab saying that 3.841. So here the decision and conclusion is what we calculated is greater than what the tabulation appears, that is 83.34 is greater than 3.84. So the null hypothesis is rejected and the alternative hypothesis is automatically accepted. So that's it for today. Thank you for watching. Have a great day.